C-Team 9, Electrical Self-Propelled Stump Grinder. DR Power is a designer and manufacturer of outdoor power equipment based out of South Burlington, Vermont. The piece of equipment that is the focus of this project is the Self-Propelled Stump Grinder. The stump grinder uses a vertically oriented spinning cutting head to remove unwanted tree stumps. C-Team 9 was tasked with taking the existing DR Power self-propelled stump grinder and removing the mechanical drivetrain to replace it with an electrical drivetrain system. The members of C-Team 9 are Project Manager Matt Chipman, Eric Roback, Testing Engineer, Zachary Beebe, Manufacturing Engineer, Brant Vermillion, Logistics Manager, and Charlie Lucier, Safety Manager and Financial Manager. The team is advised by Professor Dustin Rand.
So Country Owned Products came to us with a self-propelled stump grinder that was already on the market but had some issues. The drive system of their current design is run off of a belt connected to the cutting head, which means that the cutting head has to be rotating at a higher rate of speed during transportation, which poses a pretty serious safety hazard. Additionally, there's a differential underneath that is needed to allow turning of the grinder, which costs CHP a lot of money and is driving up the cost of their final product. Finally, the system is pretty complicated and adds a lot of potential mechanical failure points to the system. So they ended up coming to us and asking our team to investigate the possibility of implementing an electric drive system in an attempt to solve some of these issues.
So we decided on using two 12-volt batteries wired in series. We used deep cycle lead acid batteries to provide us with an ample discharge rate versus using a regular lead acid battery, which when discharged and not recharged immediately will actually hurt the longevity of the battery. So our original design for the potentiometer / trigger housing relied on a throttle cable that would send down to a separate box all the way down on the base of the frame, and that seemed to be a little troublesome because it's more parts that are farther away and there's not a whole lot of space closer to the engine. So we decided on 3D printing our own housing with our slotting potentiometer inside, a return spring, and a 3D printed trigger assembly. In order to control each wheel independently, there's a throttle assembly on either side of the handlebars. As an added safety measure, we have a key that has forwards and reverse capabilities and is removable to prevent any further use of the stump grinder. A secondary switch is also used to fully cut power to the motor controllers.
We're using two different independent motor controllers to power each individual motor, left and right. And the way they do that is they receive 24 volts constantly, and with our variable resistance inputs up here at the trigger level, the boards themselves are able to kind of modulate the current using pulse width modulation. That pulse width modulation is based on the trigger inputs, and the motors draw variable amounts of current based on how far the triggers are pulled. And when the triggers are pulled further, they'll draw more current and therefore go at a higher speed.
So in order to add the additional sub-assemblies to the new stump grinder, we needed to do some fabrication. So a few of the things that we added are the battery platform, which is made out of 11 gauge steel sheet metal, and then 1 inch by 1 inch angle iron and 1/8 inch thick. They were butt welded together at 45 degrees to give this nice rectangular geometry. It's very strong, so it can withstand the weight of the batteries and the forces of the cutting head. A few other things that we had to fabricate ourselves were the subframe for the motor mounts. The motor mounts are also made out of inch by inch angle iron, and it's located underneath the stump grinder with threaded rods welded onto it so that the batteries can slide right onto it and be disassembled easily. These were all made in the machine shop at UVM.
One of the specifications that we needed to verify was that the stump grinder could travel 100 yards of distance on one single charge of battery. To perform this test, the stump grinder was taken outside and put on a track that was pre-measured before the test. The stump grinder was then continuously run until 50% of the battery was remaining. The result of this test was the stump grinder traveling 11,000 feet with 50% battery remaining, which was grossly over the amount that we needed to meet. Because of this reason, we recommend that the client reduce the battery size. That way they can closer reach their goal of only 100 yards.
To ensure that our stump grinder, once fully assembled, was able to actually meet our specification of being able to go 3 miles an hour up a 20-degree slope, We took the stump grinder itself outside here on campus and did some driving around. We used an inclinometer to measure out a 20-degree slope and conducted 5 to 7 trial runs of actually going up the slope itself, just driving at full speed. After having done so, we were able to measure the stump grinder having gone an average of just over 3 miles an hour very consistently.
The new electrical drive system for the stump grinder is an improvement upon the system in a few ways. One, the safety of the stump grinder is improved by not using the cutting head bit as a source of power. This completely eliminates the chance of the user becoming injured while transporting the stump grinder from one location to another. Both cost and the amount of failure points are also reduced by adding our new system in, by taking away the differential from the drive system.
Some of the future directions that the CHP self-propelled stump grinder can take are that one key switch can be implemented into the control of the stump grinder rather than 2 to turn on the cutting head and the electric drive system all in one key switch. Secondly, alternator can be coupled with the combustion engine to charge batteries for the starter and the batteries for the electric propulsion system. And lastly, the batteries can be minimized to a smaller size in order to complete the distance range spec.